Welcome back, everyone. So this is the last session of the ABI Research Forum. So this is our panel discussion to talk about the theme of the forum, the theme of the day. So the moderator of the panel discussion is Merryn, Deputy Director of the ABI. So I'm going to turn it over straight to Merryn. And yeah, so we have until about 4:40, 4:45, something like that, to have this panel discussion. So I'll leave you with the questions that we got so far, and we may have some other questions roll in from Twitter. But otherwise, you have the floor.
Great. This is kind of like my work's done for me. I always like that. So we have a panel of esteemed academic colleagues, both from within ABI and their collaborators from outside of ABI, who are here to answer questions about their collaborations, and we have some preloaded questions here already. But I thought it would be good if we could start off with everybody going through and just introducing themselves very briefly, telling us just a very little bit about what your field is. And then perhaps, so we've got pairs of collaborators here sitting next to each other. So what is it that your collaborator provides you with that you can't do on your own? So we'll start with you, Greg.
So I'm Greg O'Grady. I'm a surgeon. I'm a colorectal surgeon up at the hospital, but I have quite a long-standing affiliation with the Bioengineering Institute as well. I actually did my PhD as a collaboration between surgery and bioengineering about 8 years ago with Andrew Pullen and Leo. And so I think I now have a really good understanding finally of how to bridge that gap between engineering and medicine. I think the power of the collaboration is really huge. It cannot be underestimated, really. I think as clinicians we have all the problems, but in general quite poor solutions to a lot of our problems. And then on the engineering side, you know, we have the potential to find great solutions, but often not identifying the key problems without clinical involvement. And it's really that bridge that I enjoy, finding the common ground and using the talents on offer at the Institute to try and solve really meaningful problems.
Hi, I'm Leo. So I'm from ABI, obviously. And so I've worked closely with Greg for about 8 years, as he said. And so I'm just reiterating a lot of what Greg said. Greg helps to kind of target our tools and our technologies towards the appropriate clinical angle. And he helps us to understand what their needs are. And I think one of the key things is he understands what the clinicians want. And so we're able to provide it, not just provide a solution, say you should use this because it's real cool. It's actually finding something that's meaningful for them and for the problem.
Hi, I'm Vinod Suresh from the ABI, and as most of you know, so I'm working with Nigel from the SBS on one of my, I guess, areas of research, which is cell culture models of human physiology. And so I like to say that I know just enough cell biology to be dangerous, and Nigel helps me to be not so dangerous. So I think what he provides is really this, you know, the detailed biological perspective and the knowledge of the techniques there, and I guess the norms of the discipline that make this, you know, that make my work and with cell culture models be, I guess, more realistic and more, I guess, scientifically valid than they would be without that kind of input.
Hi, thanks. I'm Nigel Birch. I'm from School of Biological Science. My background's biochemistry, cell biology, molecular biology. Our research is really in two spaces. We work in the neuroscience space. We're interested in proteases and protease inhibitors, processing of multivalent neuropeptide precursors, neuronal communication, neuronal growth, neuronal death. I'm part of the new brain core, and we work in an Alzheimer's model looking at the effects of phytochemicals in Alzheimer's disease, so we do that. All of that works mostly in cellular models, so we tend to work mostly in rodent systems, cell culture systems, to provide the models that we need. And I guess that frustrated me a little bit occasionally. I wanted to work in some human models. And then along came Rod Dunbar, who you heard about this morning, was working in, in human immune cells. So convinced him that we could perhaps work in some human models, and the human immune system has some perhaps slightly surprising similarities to the nervous systems in terms of communication, in terms of synapses, in terms of migration. So we've developed some very interesting research in that area as well. All positive, except for the fact that humans have this annoying trait of being variable. I used to enjoy working with cells and inbred mice, which aren't variable, so now we've got a new challenge that we have to deal with, but that's all good. So I enjoy working with Vinod, so as I say, we sort of contribute some of the expertise in some of those cellular areas. But actually our own research is migrating, ironically, closer to some of Vinod's research interests in terms of migration of cells across cell barriers, extravasation, things like this. And I think, and what Vinod, I think, brings, well, I know what he brings to our collaboration is a different thinking. I trained as a biochemist. Vinod trains as an engineer. We both look at the same problem and think about it in different ways, and so then we can come up with different solutions to approach that problem. And I think that is tremendously valuable, and so that's probably one of the major contributors at this stage, and as we potentially move closer together, I think there'll be more benefits.
So I'm Justin, and from the ABI. I've worked with Jill for the last 6 years now, I think, ever since I came back to New Zealand. And our collaboration started off with an HRC grant. That's got us started. What Jill provides me, a bioengineer with certain skills in mathematical modelling and so forth, she provides me with the most important thing that we engineers always look for, and that's validation. She provides me with in vivo, in vitro data, DNA, micro-CT, all the things that engineers look for to make our models stronger and get our models published. And also opens up a whole new stream of grants that I could apply for that were typically not accessible to me. So HRC, AMRF, and these kinds of things which typically engineers don't go for. So.
Thank you, Justin. Well, working with the ABI is an absolute pleasure. I've been in biological sciences, so molecular and cell biology, particularly with bones, for more years than probably most of you have been around here. And I only in the last 6 years, I've got involved in a multidisciplinary area of regenerative medicine, and this has just opened up, so it's fascinating, absolutely wonderful that I've got the wonderful bioengineers like Justin to work with, who absolutely asks questions that we don't even think about really, and they're actually really important on how the bones are working, whether it's the bone turnover between cells, or whether it's what the fractures are like in human fractures and other rodent model fractures. He asks questions that enable us to build more an understanding on how the bones actually act. And when they don't act properly, when they're broken, how we can assist in regeneration. Justin and I work with not just the ABI and the biological, but also with orthopaedic surgeons. So I feel very much towards the clinical side, and the questions saying that how do you, this translational medicine, it actually takes just more than one head. The orthopaedic surgeon doesn't have all the answers, he knows that, and comes to have a coffee with me and say, look Jill, I want to pull off the scaffold from the third row of the shelves in my operating theatre to fix this lady's tendon because she's never going to walk properly again unless you do. Well, that's a good biological question, and it's one we would never have thought of. But we can't do it without material engineers and bioengineers to work together to solve this problem. Fantastic, fascinating area to be involved with, and I'm very glad that I met Peter Hunter many years ago to get into this area, and then he pushes people like Justin towards me. So I'm looking at you, so.
Great, thank you everybody. So shall we start by seeing if we've got any questions from the floor? So I hope you're all going to be raising your hand. And Tor, you look like you, oh, that's fantastic. Do you need this?
I'll ask a question, and it's one that's maybe directed to Greg in terms of the engagement with clinicians. And it's true that I think we need to do more to engage with clinicians early on in research so that we don't go off and design and engineer something that would never find its way into the clinic. But the question comes, well, at some point you could think outside the box to a new solution that may not be clinically relevant now, but could in the next 5 or 10 years be absolutely game-changing in the clinic. And there's kind of maybe a fine line there between what's useful now, which might be just incremental steps in what you're doing in the theatre, as opposed to thinking, well, 10 years from now we could completely have a different system or a different way of approaching the problem. So I'm wondering how you kind of address that, because it's a blue skies research versus an incremental change in technology.
Yeah, I see your point. I mean, it's a good question. I think there's obviously a balance, isn't there? And you need that vision in order to do something really significant where you're looking long term and trying to change the way things are fundamentally done. But you also need to make concrete steps, don't you? So it's about, I think, finding the right clinician, and it's not easy, but there are academic clinicians, some who have that sort of vision and want to think big. Many of them don't. Many of them just want to carry on with what they're doing and, doing their blueprint for how they do their clinical business. So, it's shopping around a bit, maybe, finding the right one, and then I think bouncing ideas just continually off is never going to do any harm. So, if you can seek that feedback continually.
So, we shop around on a regular basis, find the right person. But let me then ask Leo, do you hide some of your science in your HRC grants, which are very much translational grants requiring kind of that you've almost done this work already before you get funded to do it? That's nothing against your group and what you do, but that's just the nature of funding in the health space. It's kind of risk averse. It's not funding blue skies research because there's high risk there. Do you, when you're writing grants and discussing the work with Greg, are you thinking, hey, here's some really cool ideas, maybe we won't put that in the grant, but when we get funded we're going to do these ideas and try them out?
No, I wouldn't put it that way. So I'm relatively conservative in general, and Greg is he's quite a visionary, shall we say. So he likes to go hard, and I think our balance is quite good, works quite well together. Our HRCs are generally quite aggressive, I think, and we get that quite commonly in the reviewers' reports. I think we have a good enough track record to convince them that we're going to get most of the way there, I would say. And we definitely tear it up. In general, most of our HRCs have some basic science aspect and a translational end to it. So we kind of tear it up like that.
A final comment on that. I think it works so long as your grant isn't dominoes, so that if the real blue sky stuff fall over, then it's all going to fall over. They won't like that sort of risk. But a little bit of risk in New Zealand is quite tolerated, I think, if you're thinking big and have the track record and hopefully a little bit of preliminary data to show that you're on rational ground.
Yeah, I think NIH is much less. They really don't like risk, but I think HRC is okay.
Just pose one of the questions I have here on my sheet. So if we're just starting with the external ABI people, from ABI, and perhaps we'll start with you, Jill. How do you find working with members of the ABI, and what are the advantages and disadvantages? Because we do want to be honest that collaborations can have challenges as well.
Well, some of the major advantages is being involved with really excellent students that can start off in bioengineering and then they ask a biological associated question and then they come and work in the lab. After we've taught them what a cell is, and some of them take to that a bit easier than others, then it's fantastic to actually work with the bioengineering people, and it's really good for our lab as well, that when they talk and work with our technicians, that they also widen their outlook. Advantages of course, I've already mentioned that Justin enables us to work on with our blinkers not quite as blinkery, and we do ask biological questions after he asks, well, how does this happen? I'm not sure, and so on. Disadvantages. I think one of the advantages of being associated with ABI is you have really good showcases, and it brings a number of different faculties in, and I think today is a great example of how it's positive. I suppose it would be nice to have and Justin and Vicky Shin and Darshini and Wilson just all available there just to pop in and say, hey, what do you think about that? But Justin's good at answering his phone. He's better at crossing Karankapi Road Bridge than I am to keep our collaboration going, but we do have continual communication. I guess it would be nicer if you were actually sitting behind us in Park Avenue or in the beer block in Newmarket, but yeah, we can cope.
Yeah, I would echo some of those thoughts. As I mentioned before, I think one of the biggest advantages that Vinod brings to the group is his thinking. We've also had an ABI student in SBS, and they bring also sort of sometimes a more quantitative analysis to some of the things that they do than we might do. So that again, we sort of there is some cross sharing of ideas. I think that given that Vinod and I sort of interact regularly, that I almost feel like I've got a window into the ABI, even though I don't, attend ABI presentations really, because Vinod knows what's going on here, and he's very open with his ideas, and so he shares that knowledge with us, down in SBS. So I think that's tremendous. Disadvantages. Distance is always a disadvantage, even though it's a very small distance, and I think I have to admit, actually, Vinod does most of the walking. so Vinod is very collegial, so he comes down and we keep a very regular series of meetings going, and that keeps the collaboration alive, and it keeps new ideas bubbling up to the surface. So it's that interaction that's really important, and I guess in 5 years' time, there'll be less walking, right? Because we'll only have to go up a floor or down a floor or whatever, and I think that actually is very exciting for the future, because I can see a lot of opportunity between research going on in SBS and ABI. And yeah, that's right. But I think that's a very positive step for the future.
Thanks. Yeah, I mean, I'd really echo the point about quantitative analysis. I think engineers, you all have a very clear, structured way of approaching problems, breaking it down, and that can't be, the value of that can't be underestimated. Not always, clinicians don't always have that approach to their problems. So a fresh perspective, I mean, if you look at science, most of the easy stuff has been done, right? So it takes groups of collaborators now to achieve anything really significant, I think. And it's that sort of collaboration that's exciting, where you're sort of at the fringes of different areas and breaking innovative ground. And I think that's what I really enjoy. The disadvantage is sometimes for us, even still, making sure you're talking the right language and understanding each other's languages. I think we've got a pretty intuitive way of doing that now, but sometimes the equations get dense and I get lost. And other times, the clinical aspects are really broad, and it's easy as an engineer to get lost. And just constantly communicating through those issues is really important.
All right, shall we get another question, Jeff?
So I have a Merryn, okay? All right. So I have a question sort of related to Greg's last comment. It almost seems that some of these really fruitful collaborations come from, sort of bridging two traditionally disparate disciplines, and solving problems in an interface that, because they're on the interface, they haven't been solved by people working in those disciplines in the past. So what's the sense, or are there pursuits in training students in that interface? And are there challenges with that sort of mentoring, from two different disciplines? And what's sort of the promise of creating a new discipline, moving forward as students are trained kind of in this meeting in the middle?
I would like to.
You want
Oh, that's you. I don't think I don't think you're training students for one new discipline. I think you're training students to be multidisciplinary, and you will never, ABI has actually been very good in taking orthopaedic surgeons and other surgeons to get a PhD, and that's automatically made them think in an outside area. But the students that I've co-supervised will ultimately go in any one of directions, I think, but possibly staying within the multidisciplinary thing of engineering with biological things, with translational, orthopedic, companion animal research, that sort of thing. So I don't think we're making a new discipline. I think we're making a better multi-discipline student.
So to just add to that, I think when you have an interdisciplinary collaboration going on, so when you have contributions from both partners into the specific questions you're asking, then that other perspective then says, well, this is another approach to this problem, and that will provide information that that you otherwise wouldn't have. So, for example, with one of the students that Nigel and I were co-supervising, so before Nigel got involved with the project, we just did some regular gene expression studies to find out whether a particular gene is expressed or not. And then Nigel suggested that we should take a more quantitative approach and use quantitative PCR, which is something that I didn't have experience at that point. And that would provide us, I guess, much more, quantifiable information that we could use. And so the student who also, she didn't have experience with that, so she trained in that. And then, she picked up a new skill, and we got a new set of data that added a new perspective to that problem. And so I think that's where the interdisciplinary approach, really shows its strength, because you then tend to, I guess, use approaches that you otherwise might not have thought of. So.
Wondering.
Just on a similar note, I guess a question for the external collaborators. If you're, for example, early career researcher, and you're wanting to, you got some ideas, you want to go and talk to someone, see if you can build a collaboration, just wondering, who would you go and see? For example, would you be open to collaborating with younger sort of researchers who may not have, for example, a track record? Or would you, would you recommend, for example, going and see another postdoc, say? Yeah, so that's something I was just interested in.
Yeah, I think, as a young researcher, it'd be really powerful to go find someone senior. It really give you not only mentorship, but also open the door to funding, which potentially, if your own track record's a bit weak, then having a collaborator with a strong track record is going to open those doors for you much more, I think. So you want to aim high, and also you probably end up with a better science out of it if you can find that person. Finding how do you find that person, you can talk around and get referrals, talk to people who know people, and just network it out, and hopefully you'll land on the right doorstep.
Yeah, I'd agree about that. I'd agree. It depends, I guess, what you're looking for, you know. So if you're looking to sort of access a new technique, you know, then perhaps you'd go to a head of a lab, and then they would probably, you know, then shift you to that individual who knew how to do the technique, because the head of the lab's sitting in his or her office and hasn't used that technique for 10 years or whatever. However, you know, if you were looking to, you know, sort of initiate one of your first grants, for instance, you know, and maybe putting an application in something like the AMRF that I'm a part of, you know, they like to support young investigators. So then you go and talk to the PI, and certainly all the colleagues I know in biological sciences, and I'm sure elsewhere, are very welcoming. We love to talk science with anybody, you know. We don't care how young or old you are. Younger people probably better because they're thinking more laterally, right? So we're happy to chat with anybody and support, you know, as you were saying, sort of grant applications.
I should just add a point that when Jill and I started to collaborate, I was still in early career, and now I'm late early career, or something like that. But and that's just grown since then. And we did the HRC grant we got was the early career HRC grant. So I think where the funding mechanism encourages that, by all means, I think one of the external collaborators who's more senior would definitely collaborate with you, and they like to see that mentoring relationship in those applications anyway. So, did you want to add anything?
No. So you were the one that sent Justin.
Do we have another question? Okay. Got to make notes here as well. So what are the funding opportunities for University of Auckland internal collaborations, and have you leveraged any of those? So are there strategic ways to leverage collaborations such as yours in order to be successful in funding? So first thinking internally, and I know that you've all been successful with external funding, but particularly if we're thinking about early career researchers who might look internally first of all.
The traditional cross-faculty funding has been a good way of bringing, in fact it's great to find someone else in another faculty that wishes to put something forward with you, and I think they have been, I mean, it's changed a little bit, hasn't it, in the last while. They're now called strategic or some other bloody thing. Yeah. But you can do it with 2 faculties or 3 faculties or together, and that's a nice way of getting early career people up and going, as well as funding the Oldfarts. What else is there? I don't know, what can't I say?
Well, there's the standard FRDFs that you get in faculties.
Yeah,
and
FRDFs.
yeah, and so they're the standard mechanism. I think different faculties award different amounts, but you can collaborate with other faculties, and that's a good way to get some pilot data. And I think FRDFs are strategically usually aimed at early careers anyway. In the ABIs, I'm not sure of the other faculties, so there's a good... Yeah, exactly. So that's typically the way to get your pilot data. And you increase your chances of getting an FRDF when you say that you're going to use this pilot data for a bigger grant like HRC or Marsden or so forth. Yeah.
So Nigel and I were talking about this just before the session, and we feel that there's been quite a decrease in internal support for for cross-faculty collaborations. Yep. So the cross-faculty fund that Jill was talking about, so that's kind of been wound down, and it's completely changed its character now. So the strategic research initiatives fund does not fund the same kind of things that the cross-faculty funds did. And the FRDFs, between different faculties are, I guess, they're a bit problematic. I mean, in the sense that not all faculties run their FRDFs at the same time, and you can't really jointly apply to the FRDF in 2 different faculties for the same project.
It's a real problem.
Yep. So there's, I mean, I don't think there's a very clear internal mechanism for, for starting up new collaborations. So for the project that Nigel and I are working on, we didn't really have any internal support as such, except that, we were co-supervising a student, and so there was, we had the press fund and so on, and we had our own external research grants that could, that could further that collaboration. But I think there definitely needs to be some thought about, I guess, rejuvenating internal university funding for setting up new collaborations.
You need to talk, Peter, to the Vice-Chancellor.
So maybe our Associate Director of Research might have some inside information.
Yeah, so they're winding down the official cross-faculty funding mechanisms, and the official word is you apply to a FRDF in one faculty and you use that as your funding mechanism. So as Vinod said, it's hard to split it. You really need to have one of the host faculties being the priority funder. And for ABI, we have a pretty good success rate. It's like a 50% rate, which is really good, and it's kind of easy money to try and target, especially if you're early career. I know, like engineering school, they have less than 20% success rate. It's really tough there.
Yeah, everything that you've heard, I completely agree with. It is more of a challenge, but I just would say FRDF within the Faculty of Science, the success rate is much higher than things like a Marsden or an HRC, so that's very positive. And I think a joint application in many cases will be a stronger application because it'll have a breadth to that application that you won't see. If I were to put an application in on my own versus with somebody else, it gets that breadth, which just, I think, generally strengthens the application because it potentially can have a translational aspect to it, or some other aspect, a model aspect to it that ABI could bring to the party that I wouldn't have. Yeah.
All right, so let's get some more questions from the audience. Jeff.
So just think, because we've been talking about sort of funding and early career research and that kind of thing, so sort of getting the PhD students more involved. So if there's a PhD student who's not involved in an interdisciplinary collaboration with their supervisor, but they're interested in one, and that's something that just for their own edification that they'd like to, to add to their experience, what would you recommend for that student?
When I was a PhD student, I looked around and I didn't like biomedical things, so I looked at the ABI and I saw some really interesting work going on down there in engineering, and I thought I'd like to get involved in that. So I just found a surgeon who I knew was very open-minded, and I said, what do you think about co-supervising across faculties? And he thought it was great. So I think just put it to them and find the right people, and they'll be very supportive, I would have thought. Yeah.
Partly, I guess it depends on the nature of the project. So if you started off on a PhD project and you got a research plan in place, then you may not have a whole lot of flexibility in saying, well, I want to go do some interdisciplinary stuff and get someone else to collaborate on it. So if it's the right project, then you can definitely try to find other people who can, I guess, add a new perspective to that project, and you get the interdisciplinary training and a new set of skills that that will broaden your CV. So it's difficult to generalize.
I think by all means, at any stage during one's PhD, if they want to get to some collaborative or interdisciplinary work and they realize that another co-supervisor is necessary, then there are very easy mechanisms to do that. If your supervisor's happy, fill out a Doc 6 form, which I will approve. And in fact, we encourage that all PhDs approved in the ABI go through a bit of a vetting process anyway, and the institute as a whole will see where there are gaps in your research, and quite often co-supervisors from other faculties are suggested, so it's quite common in the ABI.
I think remember the ABI is often not on the radar, especially of clinical people up there, like molecular medicine would be. And so I think it really helps to sort of have a bit of a presence and put yourself out there a bit. And often, the surgeons I've spoken to find it really appealing working with engineers because it's very practical and design oriented and things. So, yeah, so if you put yourself on the radar a bit more, I think opportunities definitely appear.
So I've got a slightly provocative question for four of you who are part of the MedTech Core, or have received money from the MedTech Core. So with funding models like the MedTech Core that incentivise collaborations between universities, does that disincentivise collaborations within the university?
I don't think it takes away from working with other universities, but I am, and not everybody I know agrees with me on this, and politically it's probably not the right thing to say, but sometimes I find it frustrating that I have to look elsewhere out of Auckland to get a grant, to get some research going, that I know I've got people in other faculties within Auckland in which I'd like to work with. And I certainly encourage those that have started up collaborations like Wilson and Justin into Canterbury to maintain that so that we can build on that. But I would like the opportunity to, in something like MedTech Core, but again, this is political, to be able to be encouraged more to work between different faculties.
Okay. Yes, I had a seed grant, that's true. But I think I'll talk more probably about the other one that I have, which is the art funding. That's a more recent one. So obviously, when applying for these, there's some rules around multidisciplinary collaboration. It's to make the MedTech Core work as a group. But I found very much with research that involves clinical trials, which is the particular one that I was involved with, and orthopedic testing, that it was very important actually to have external collaborations, in this particular case with Christchurch, and to use different district health boards, to evaluate our work. And so I think in that regards, that was the only way to make our project work. But I do take on board Jill's point that sometimes we're finding ourselves perhaps maybe collaborating with, for example, AUT Gate Lab, when we could probably just use the Gate Lab at Auckland University, but you're ticking the box in order to satisfy the criteria. I'm not sure how they would see if you were just using both Gate Labs as just redundant, but yeah, we sometimes do a bit of box ticking, but I think definitely with clinical work, the spreading your wings a bit and collaborating with the other universities is almost necessary. So in that sense, the MedTech Core is probably right.
I think every funder has their rules, and every funder is going to have a rule that you don't like. There's going to be rules like money can't go to overseas, money can't come to us, you're too old, you're too young, that sort of thing. And I think you just think of MedTech as we're really lucky to be able to access this sort of funding opportunity. And I think I still work with Greg, but we try and work with some guys in Christchurch as well. And there are other mechanisms if we wanted to just work with Greg and not work with anybody else as well. So there's other opportunities, I think.
Yeah, I mean, the marriage of convenience we've had with a couple of different people, it's actually gone pretty well, and you sort of don't know these people from really a bar of soap when you start working with them, but it does stretch your mind a bit to sort of see what other people are doing out there, and you discover common ground, and a couple of things we're sort of rolling along with a bit, so it's been good from that point of view. I think that the main downside for us is when you get other institutions involved and you actually get some success and you file an IP disclosure, then it gets messy with two universities doing things. I find it a bit of a headache, and then so that's been a downside for us, but overall I think it's okay.
Surely I've asked enough questions. Where's the next one coming from? Marty? No? Andrew? You're shaky here. Oh. Tony?
Honestly, I think it was
So how does the IP work with NetTech core funding?
Yeah, so it works the same as any other thing you do with the university. You just submit it through the Uni Services portal if you have an idea to disclose, and then you sort of take it from there with Uni Services advice. But you do need to include the contributions of other people. If they're outside, then that can be a minor complication.
Ping.
I think we've heard a lot about what makes a good collaborator. So I'm going to ask a slightly negative question. And not, anything specific, but I'm just wondering what makes a bad collaborator, or i.e. risks you would avoid in a good collaborator.
Who wants to answer that one? It was fast.
So I have a whole lot of collaborators all over the world. Some are really good and very responsive. Some are not good and not responsive, which really annoys me. And then people that refuse to establish any collaboration, so those don't actually work at all. And so I think you just have to deal with it and decide whether you're willing to try and keep pushing ahead, willing to put in 99% of the work rather than 50% of the work, and weigh up the pros and cons, I guess. I think for me, communication, in particular email, I guess, is one of the real critical things that I see in a collaboration. I need to be able to communicate efficiently with somebody, especially if they're overseas.
So I'll answer that by telling you what I think is a good collaborator, and then you can see obviously what the bad collaborator is. So I always felt that a good collaborator is where you get everyone at the table at the beginning of the project when it's being composed and designed. It's very important for modelers because quite often we're asked at the very end, would you mind doing a little bit of modeling as almost an afterthought? That's bad collaboration. You should really be there at the beginning of the process, making sure that everything you need for a good model is being collected and measured and so forth. So the answer is a bad collaborator is essentially coming to the table right at the end too late. I think that's bad collaboration. Yeah.
I might just add to that too. I think a bad collaborator is one that you can't build further research grant funding or ideas from the collaboration. We have, both Justin and I have been involved in a European Union URSUS grant and in skeletal regeneration, and if we hadn't have collaborated together, we would never have reached the partners that we did in the UK. And when Justin went off to do his meeting and greeting with his different collaborators, he would see a whole different aspect and a lot of people within a university, such as University of Southampton. I don't think he hardly ever went to see the guys that I did, but together we were able to lead through and make these extra collaborations, and they're going on further too. And I think a bad collaboration wouldn't have led forward on. It's very important.
I would just say the key is communication. A bad collaborator just doesn't communicate. It's a one-way interaction, and that is just never successful. So the key is communication, I think, and if poor communication is not going to lead to a very positive outcome.
And to add to that, I would say it's delivering on your promises. So if you start off a collaboration and you're expecting data or a model or even I guess feedback on a manuscript or a grant proposal, and that needs to be that you need to deliver on that, and you need to do it in a timely fashion. And that's key to to ensure, I guess, trust on both sides, as well as the the practical aspects of of making things work.
So I have a question from Twitter, which is, how did you meet?
Married at first sight. Yeah, no, I actively reached out to Andrew Pullen at the time because I thought he was doing interesting work and just wanted to get involved. It's pretty simple for us.
So I had a PhD student doing a cell culture-based project in SBS, and so Nigel and I were sharing that cell culture space, and eventually, at first, we were just using the cell culture space, the same cell culture space, and then we got around to co-supervising the student, and then that flowered into a deeper collaboration.
So I was preparing an HRC application, and I was looking for, it was an early career one, and you needed a senior mentor and someone who was very experienced in the field. So Peter suggested to me, Jill, across the bridge. So I walked across the bridge the very first time, amongst many, and I camped myself outside of her office and waited for her to return, because I think you were slightly busy. And when I went inside, I just basically, I wouldn't say sold myself, but I marketed myself in a way.
He sold himself.
I basically gave an overview of all the skills and talents that I have.
He's not shy.
And then she was impressed, and then and then that's where I went from there. And then so she's always thought of me when she comes to modelling from that way. Modelling, computer modelling.
So maybe we can just carry on then, and you could talk about how you've maintained your collaboration.
I think it's been extremely easy to maintain the collaboration with that European Union grant, particularly the MedTech core, and even more so perhaps the students. And the students have just come and seems to roll on, having ABI students in the lab, and it's phenomenal. And I've got to the stage in my life like being mother and seeing these students doing really well, getting awards, and having one with a lot more energy than I have to keep everything going.
I think we keep it going for really, I guess, a common passion for science, I would say. We both have sort of broad interests in science, and we talk about a lot of different things, and I think, I get excited by any bit of science pretty well. And so it's just a passion for science, and we've shared students, and we'll share students in the future. So, and I think that helps.
Yeah, I think it's regular meetings, regular communication. So so we are engaged with the project, and we are both I guess we share the same level of knowledge about about the collaborative effort that's going on. So that's really key, and having a joint supervision of students, that's also really been helpful to keep things going.
Just to add one more thing is just to say that communication factor is so critical, and Vinod, to his credit, when he can, comes down to our group meetings and brings his intellect and thinking to projects that are not the one that we immediately collaborate on. So it's that willingness to participate in science that leads to success. I think successful collaboration.
So Greg and I have a very strong collaboration, but things are not all rosy. So it's always challenging with Greg because he's always got an excuse. I was busy saving a life. I couldn't come to the meeting. And so quite often I'll literally tell him one time to meet, and I'll tell the other guys half an hour later. He doesn't know this yet. And he'll normally turn up. Greg's really good. So he'll come down the road. We've hardly ever meet up the road. We always offer to go up the road and find him, but he'll always come down and find us. And I think he's willing to put in the work and come and look for us, I think. And we're both really curious and passionate about our science. I think that's what keeps it going.
Great. Well, we've used up our time, so unless there are any more burning questions from our enthusiastic audience, then I think we'd like to thank everybody who participated in this panel. Thank you for all your insights.